Hello to Tommy in Norway. Here is your diagram. Does it have a bunch of numbers? No. I don't have the time nor the inclination to go out on a large lake, have somebody go out in a boat, measure all these things off. If you want to do that, you can. But you know this is going to be how it works, because this is what you see in reality. This red line down on the bottom is the ocean, or a lake, whatever water surface. If I'm standing here right at the shore, right where the water's lapping up, I look down to see the water right at my feet. I'm, 6 feet down, right? But when I look straight across, the horizon meets my eye level. The water appears to slant up to it. Now, this water behind that point doesn't drop down. It doesn't go down here or curve down here. This is the surface of the water all the way across the body of water you're at. This is the line where you can't resolve things that are close to it, because you have a variety of factors. You have the atmosphere, heat waves, small little waves, just things like that. Angular size. The further something gets away, the smaller and more squished it gets. Well, anyhow, at this point, this is my horizon. Sorry it's a little windy out here. My shade just about blew over on me. This is the angle I keep talking about. This is the optical limit of angular resolution, is right here at this point. This is what the flat earthers were making mistakes at, because they were thinking they could bring everything back into view, complete view. Well, they could if it was up to this point. What they were observing is that sometimes they couldn't see something of small angular size because it was in this little part of the angle. And with binoculars, and they could see it again, because the binocular basically acts like a microscope into the small part of the angle. Microscope at a distance. That's how they were getting fooled. And that's how they made a mistake. I knew all along that boats would disappear, because you could see it. So anyhow, but this is how it works. Your eye level makes the horizon right here. The water appears to slant up to it, and then it's just straight across. You're not looking down over here to see the water. You're just only when it's at your feet in this first little distance, but to see the horizon, eye level. The boats, if there's a boat before this point, you can see the whole boat. Behind this point, you can't. It starts to disappear bottom first, plus it diminishes and gets smaller in angular size as it moves away. And then ultimately it gets lost in here. It's kind of like if I laid a paper on a table and I tried to peer under that. That angle would be so small I can't see anything in the back part. But if I raise that paper up a little bit, I can see, because I changed my angle. Well, this is how I bring a boat back into view. I rise up. Well, that changes my angle. This part becomes wider. See, here it was this wide. Here, it's this wide. But not only does that part change, this part changes. This first one was here. But now the water is a more gradual slope up, goes off into the distance, meets you at eye level. Now this boat, because it was behind this and was disappearing bottom first, is now in full view because it's within this whole wide part of the angle. It's no longer behind and on the flat part. It's right there. You see it in your own videos. You see it in my videos. That's how it works. That's how your eye works. Everything below eye level slants up to it. It's just that simple. And the higher you rise, the further you see, because you widen the angle and lengthened it. If I want to obscure this boat completely, and partly this one, all I got to do is just lay on the ground and look out, because now it'll go I'm going to be down here, that little angle is just sharply up and it's over here. And that's where the boat would disappear, because it's already behind, way too far behind my optical limit. That's why rising or lowering in elevation radically changes where this point is. Now, if you want to get someone on a boat, go out, watch them go off into the distance, measure off where it starts to disappear bottom first, measure it to you, then you can figure out what this angle is from your height up to that point. Then you can measure your angle. That will be your optical limit of angular resolution. The same with this one. Now you would measure here to where the boat was just going to start going bottom first. That's your angle. You would find your distance here, you find your distance here. This is the one you can't measure with regular geometry, the one that goes up, because that's how your eyes work. And your geometry doesn't have something for that. Your geometry just counts a straight line. We got a straight line. My eye view has to look straight across. This has to be straight across. This has to be. It can never meet, because parallel lines never meet. No, parallel lines never meet. But perspective in your eyes, things merge. That's just how it works. And you don't have to like it. Doesn't matter. That's reality. This is the real world. This is how your eyes work. This is how your cameras work. It fits this model. You can figure this out. You seem pretty smart with this kind of stuff. But you have to know that this is always going to happen. Your eye level here, the water's going to rise up to it. Here's going to be your water level the rest of the way across. You're not going to be looking at this down here, because that's just not how your eyes work. You saw it in my videos. That's why I can stand with the pipe on a level. I can have the pipe on the level and be well above the water or the valley and still see the horizon in my tube. It's because that's how it works. It's just simple. Works every time. You can debate if it drops a teeny bit. I don't think it does. But you can debate it if you want. That's fine. Doesn't matter. Because still the fact is, you're looking straight across at your horizon, no matter what. If I was 500 feet up here, I couldn't fit it on the paper, but I would still have the same thing. This line would go off over here somewhere, and then this one would meet it. I would change the angle, see further. That's why on Lake Pontchartrain, there's a lot of pictures, overhead pictures. That thing's flat as can be. There's no hump. See, and this is why too, when you rise in elevation, this is why your hump levels out, because this line, instead of being here and now here's your hump and you think the curve is going over here, this is what happens, and you see it when you do it. When the camera goes up, you see this lowering and it going off into the distance further. It's in all my videos. Just look. It's even in yours. The thing is, you don't notice it in yours so much, because you usually go to one elevation and stay there. And then you just say, oh, look, the bottoms of this are gone. Explain it. You can't explain it. It's beyond the curvature. There's this much missing. This is why. Your eyes have a limit. It's for depth perception. You were created by God to be able to judge distances. How He did it, how they work, I don't know. I just know that's what we see. And that's why if the sun was over my head, it would appear to slant down in the distance and come down here. And you would see it the whole time, and once it got behind this line, it would start, unless it's got mountains or something, but if you're on the ocean, once it gets behind this line, it will start going away bottom first. And yes, the sun moves in a straight line across. It doesn't arch. That straight line, though, in our eyesight, appears to slant down. The clouds, if there's clouds here, the clouds will slant down. They'll meet the same point. The clouds and the sun, the moon, they all meet at the same point on the horizon. The angles are just steeper for the sun because it's higher. and for the moon because it's higher. And the clouds, it's still a steep angle, but not as steep as like the sun or the moon. The stars do the same thing. That's why everybody has a hard time figuring out the stars, including you guys. You guys can't explain certain things about them. Neither can we. But we're figuring it out. We got some pretty smart guys on our side, and we're having fun. You guys seem to be pissed off all the time. I mean, the anger I find on your guys' side is crazy. I literally get threats. Like on Facebook. I stopped going to the NASA page because I would have people message me, message my wife with threats. Anyhow, YouTube's much funner. It's too bad half of you guys block me. But it's still fun. I like arguing with you guys. By the way, Tommy, I'm not your enemy. I'm sure if you lived here, or if you came here, here's my offer to you. If you ever come to California, find a way to message me, either on Facebook or on YouTube. And I'll take you to dinner. We'll go to Monterey or Carmel. Two of the most beautiful places. They're side by side. Two of the most beautiful places in the world. And we'll have dinner or lunch out on the ocean. Okay? But I still like to ridicule you guys, including you. And I'm going to make fun of you. But just because this is kind of fun. Well, anyhow, you have a good day.